All right, guys, so we're going to talk today about what is a function, okay? So a relation, okay, or a relationship is anything you can plot on a graph, and that could be a graph, it could just be points, okay? So pretty much anything I give you can be plotted on a graph. So anything I give you is a relation or a relationship. What is a function? A function is a relation, okay, that becomes a function if and only if for each member of the domain there exists one and only one member of the range, okay? So let's make sure we follow this. If and only if for each member of the domain, okay? Let's make sure we know what the domain is. A lot of math students think the domain is X. That's not actually true. Domain is the independent variable, okay? Which in the case of any problem we come across is the horizontal axis, okay? Which in math is the x-axis. But I like to make sure my students understand it's not just x, because if you go on to physics or engineering, you get an equation that has no x and no y, and then you don't know what the domain is. So the domain is the independent variable, which is the horizontal axis, and specifically the independent variable is always your input, okay? And so if you have an equation and you're going to plug numbers into it, whichever letter you plug those numbers into, that is your domain. That is your input, okay? And your range, let's talk about the range. The range is the dependent variable, okay? And what that means, okay, is that it depends on the x value. So if I plug in an x value of 1, whatever I get out of that, so that would be my output, right? So if you've ever made a table of x's and y's, you plug the x values into an equation to get the y values. That makes it dependent on the x values. And this, of course, will always be our vertical axis, okay? The vertical axis is always dependent upon the horizontal axis, okay? So input and output. So let's go back to our definition. It says a relation is a function if and only if for each input, okay, so you plug a number into an equation, there exists one and only one output, okay? And we'll get to that in a second. That'll kind of make sense, okay? So let's scroll down and we're going to ask some questions. Is the relation a function? So yes or no question, okay? It's a yes or no question. But if you just guess yes or no, you don't really understand functions and relations. So here goes. All right. So is this relation a function? Well, here's an input and we get one output. Here's an input and we get one output, right? One input, one output, one input, one output. But look here, one input, what do we get? Two outputs. So this violates the definition of a function, and so the answer is no. This relation is not a function. Okay, let's go over here. This input leads to one output, this input leads to one output, input, output, input, output, input, output, input, output. All of these inputs lead to what? One and only one output, so this is, yes, this is a function. Last one. This input leads to what? Two outputs, okay? So immediately we say what? No, it's not a function. But look here. This also makes it not a function. And then these are fine, but doesn't matter. If you break the rule once, you're done, okay? So why are functions important? Well, if you go on in math, and if you don't go in math, you're not going to care. But if you go on in math, there are a lot of rules, a lot of theorems in math that specifically say this theorem only works for functions, okay? So you have to know what a function is to apply these theorems. Now, of course, we rarely give you tables and numbers. We normally give you equations or graphs. So we're going to play with equations and we're going to play with graphs. Okay, so is this a function? Yes or no? All right, you have a couple of options. One option is to know what this picture looks like. Well, I know this picture is a straight line, and that tells me something. But the other is to just actually be creative and think. Okay, here's my input. Okay, here's my input. Okay? Pick some numbers and plug them in here. Doesn't matter which numbers. pick some numbers and plug them in. Let's say I plug in the number 1. Well, 3 times 1 is 3. 3 plus 5 makes what? 8. So an input of 1 gives an output of 8, right? Ask yourself, is there any other possible output if I plug the number 1 in? The answer is no, okay? Try 3 or 4 numbers. Here's what you'll realize. You plug in one number, you're always going to get what? One answer. That means yes, this is a function. Okay? This is a function. Okay? How about here? Oh, I have 2 places I can plug an x in, right? So these are both my inputs. So these are both inputs. Okay? Pick a number. I'll pick 2, right? 2 squared is 4. 3 times 2 is 6. 4 plus 6 makes 10. What's 10 minus 12? Negative 2. So my output would be negative 2. Okay? Am I going to get any other answer? No, I'm not. Okay? Try 3 or 4 different numbers. For every number you plug in for x, you will get one answer. Yes, this is a function. Okay? Cool. All right? How about this guy? Well, let's say I plug in the number, I don't know, let's plug in the number 1. Okay? So if I plug in 1 here, right, 1 squared is 1. Okay? Solve for y. So I'm going to subtract 1. So I get y squared equals 15. And then I'm going to take the square root of both sides. Now, what do you do when you take the square root of a number? You're supposed to put what? Plus or minus. Okay? So I plugged in 1 input. So I had 1 input. And what did I get here? I got 2 outputs. Okay? 2 outputs. 1 input, 2 outputs. Is this a function? The answer is no. It is not a function. Okay? Not a function. Now let's look at this graphically. Okay? Graphically. Okay? Pick an x value. That's our input. Go down to our function. Boom. We get what? 1 y value. Pick an x value. Boom. What do we get? 1 y value. Pick an x value. What do we get? Boom. 1 y value. Okay? For every x value that you select, you're going to get 1 y value. For every input you select, you're going to get 1 output. Okay? This leads us to a thing called the vertical line test. You notice an x value draws a vertical line. And every one of those vertical lines is going to hit this function in one place and then go over horizontally. That would be your corresponding y value. Okay? So yes, this is a function. Yes, this is a function. Same thing here. X value, draw a vertical line, go over horizontally. What do we get? 1 y value. Draw a vertical line, hit our function, 1 y value, right? Draw a vertical line, okay? And that's called the vertical line test. Yes, this is a function. Yes, this is a function, okay? How about this guy? Draw a vertical line. What do we get? We get a y value here, and we get what? A y value here. I get what? 2 y values. So no, this is not a function, okay? So if you have the graph, you can use the vertical line test. If you don't have the graph, let's go back to the equations for a second, okay? If you don't have the graph, okay, notice y to the first, x to the first, okay? What that means is 1 input will give you 1 output. Y to the first, x squared, okay? What that means is 2 inputs will give you 1 output. That is still legal. 2 inputs can give you the same output, but each input only gives 1 output, okay? Notice here, both squared. What this means is 2 inputs will give 2 outputs, okay? What that basically means is I can plug in 2 x values to get plus or minus root 15. But either of those x values will give me plus or minus 15, i.e. 2 outputs, not a function, okay? So if you really want to stare at an equation and play with it, you can, and I strongly suggest you do that. Take this, solve it for y. You'll end up, if it's squared, you'll take the square root, you'll end up with 2 outputs, okay? And what you'll find every time, if this guy's squared, you're going to get 2 outputs. If this guy's cubed, you're supposed to get 3 outputs. And so the power of y tells you if something's a function or not, okay? And there's a few very rare exceptions to that, but for 99.9% of the problems, if y is a first degree, right, y to the first, you're going to have 1 output. Bam, it's a function, okay? If y is squared or cubed or to the 4th, you're going to have more than 1 output. It's not a function, okay? One last thing just for fun is domain and range from the graph, okay? So remember these little arrows that are at the end of our graph here, these little arrows at the end of our graph, they mean the graph keeps going forever and ever and ever, okay? So there's some peak here, okay? And we'll know this coordinate. Let's say that's 5 on the y-axis. Well, this thing goes from 5 and keeps going down forever and ever and ever. So what's the range? The range is negative infinity. Paper keeps moving, that doesn't help, to 5. Okay, and 5 is included because it hits that point at the vertex. Well, what's the domain? Well, look at this arrow. This says it's going to keep going down and to the left. This says it's going to keep going down and to the right. So the domain is all real numbers or negative infinity to infinity. Okay? So, and you can find that real easily with the graph. Okay? All right, cool. So, domain. Well, it keeps going left. It keeps going right. So the domain would be negative infinity to infinity. And what would the range be? Well, this is going to the right and up. That's albeit it's going up slower than it's going to the right. And this is going down and to the left. So it's going to keep going up. It's going to keep going down. So the range would be negative infinity to infinity. Okay? And this equation would be y equals x squared. It's a function. This equation would be y equals x cubed and some other stuff, but the other stuff doesn't matter. Notice y is to the first, y is to the first, right? Cool. Let's come over here to this guy. So we're going to have some peak. Let's say that's at 5, and let's say that's at 1, okay? And let's say this over here is at negative 3, and this over here is at 7, okay? So we got the width and the height of this ellipse-shaped thing. It's supposed to be an ellipse. It kind of looks like an egg. I'm not good at drawing ellipses, okay? So if this thing goes from negative 3 to 7 on the x-axis, the domain would be negative 3 to 7. And if this thing goes from 1 to 5 on the y-axis, it would be 1 to 5. And remember, because a lot of people boo-boo this one, okay? Always go from lowest to highest. Lowest to highest, lowest to highest, right? Left to right, up, right, bottom to top. Okay, lowest to highest. That's how we count on the number line. This equation, if I were to write out this equation, would look something like x squared plus y squared equals 1. Okay, that's the equation, basic equation of any ellipse, and we transform that. But what do we notice? We have a y squared in there. It's not going to be a function. So anyway, domain and range and how it pertains to the definition of a function, that's real quick and dirty. I really hope it helps somebody. I know this is a sticky point for a lot of students. If you have questions, leave them in the comments and I will do my best to help you.